Hello everyone. Today we will continue our topic with hyperconjugation. Hyperconjugation, also known as hyperconjugation, also known as Baker-Natham effect, or no bond resonance. That is, it is a type of resonance in which delocalization of electrons takes place through overlapping of sigma bonds and p orbitals. That is, electron transfer takes place, or delocalization of electrons. That is, it is a type of resonance in which the delocalization of electron takes place through overlapping of sigma bond with p orbitals. Not only sigma bonds but sigma or sigma star. Both can be used in electron transfer. In this, weak bonds participate. Okay, so hyperconjugation can be categorized into two, that is sigma bond and p orbital overlapping. We will see how. And sigma bond with pi star orbital overlapping. Okay, so the example with a hyperconjugation with the sigma bond and p orbital, that is carbocation and free radical, in which there is lack of one electrons, whereas sigma bond with pi star orbital, that is alkene and alkyl benzene. So these can be taken as the example for hyperconjugation. So let's start with hyperconjugation in carbocation. The structure of carbocation is carbon attached with 3 hydrogen atoms, single bond, and having plus charge, that is empty p orbital. Okay, electrons, since this carbon has deficiency of electrons, bonds of CH bond, because of some difference in polarity, bond breaks and this formation takes place. That is, electrons are somehow donated into from this sigma bond to this vacant p orbital. So this H and this H. Now the deficiency of this carbon decreases, but the hydrogen, that is the bond which is breaking, the hydrogen remains. And there are three possibilities that any one of these hydrogens can take place in this hyperconjugation. So either hydrogen number 1, or this. That is, this can be one structure. If we can say second one is if this bond breaks, then this can be the second possibility, and this can be the third possibility. Since all three structures in this are same, okay, so to calculate how many number of uh, structures, means how many conjugating structures are present, can be calculated by presence of number of alpha hydrogens. That is, more the number of hydrogens, alpha hydrogens, more is the number of higher the number of resonate hyperconjugating structures. So as the number of alpha hydrogen increases, and which is alpha hydrogen is the hydrogen attached to alpha carbon, and alpha carbon is the first carbon that is attached directly with that carbocation. So next, after seeing hyperconjugating structures in carbocation, next is hyperconjugating structures in free radical. So the structure of free radical is C double bond C. Okay. This, for example, this is hydrogen. So the and this having one electron. So the this this one is somewhat. So actually this is single bond. Okay. So carbon single bond carbon having one electron in its p orbital, and this carbon and hydrogen bond. So electron transfer takes place from this CH bond to this p orbital having one electron. Okay. Then in alkenes. So in alkenes, alternate position पे अगर double bond होगा, that is if double bond is present at alternate position. Okay, like this is an alkene, and to this carbon there is some hydrogen. That is, since this is double bond, so the carbons or the carbons so attached with it, either this or either this, will be considered as alpha carbon, and then hydrogens attached to it are alpha hydrogen. So and this let's say these all are H. So these, one of these bonds can be taken here, and transfer of electrons to take place. That is also can be termed also as resonance. But here number of alpha hydrogen is equals to number of hyperconjugated structures, and as the number of alpha hydrogen increases, number of hyperconjugating structures also increases, and hence more delocalization of electrons takes place. That is, as as number of hyperconjugating sorry, as number of alpha hydrogens increases, ठीक है, जैसे alpha hydrogen के number increase होंगे, number of hyperconjugating structure number of hyperconjugating structure वो भी इंक्रीज होगा, और जैसे जैसे hyperconjugating structures इंक्रीज होंगे, delocalization इंक्रीज होगा. That is, in delocalization of electrons increases, hence means and as delocalization of electrons increases, then stability on the alkene or whatever carbocation or free radical, anything increases. So overall, as number of alpha hydrogen increases, stability of the compound increases. Okay. Reverse hyperconjugation can also take place, that is negative hyperconjugation. The term is negative hyperconjugation. So this is overall conclusion that can be brought out from this hyperconjugation. Okay, now negative hyperconjugation. Negative hyperconjugation. So electrons taken, okay, from pi electron system can be termed as reverse hyperconjugation. Like this is a benzene ring connected with a carbon, or let's say any group is present. Let's say it is an electron withdrawing group. So this one shift takes place. Okay, so this is here, it attains a positive charge. This and this having double bond gets double bond, and this to balance this positive charge, resonance यहाँ पर आएगा. This is also a resonating structure. Since resonating structure means they have same structure. Okay. Yeah. Next, after that, to balance this one and this, and it having a means negative x negative, then again attack. So this is a reverse conjugation, reverse hyperconjugation. Okay. Now hyperconjugation can also we can say hyperconjugation into two, or divide hyperconjugation into two, that is plus H and minus H. Okay. Plus H means with the group any electron releasing or electron donating group is present. Electron donating group is present. Okay. Electron donating group is present. Whereas with minus I, it is electron withdrawing group present. That is takes up electrons from it. So this is only known as